We continue Unit 13, Graphing Rational Functions, with flaps 2 and 3 in our foldable. To graph a rational function, we first find the vertical and horizontal asymptotes. We discussed this in flap 1 of our foldable. Then we graph those asymptotes as dashed lines. Make a table of values to get the points on the graph, and then plot points and graph the function using asymptotes as boundary lines. Look at the function f of x equals x plus 2 divided by x minus 1. We first need to find the domain. Set the denominator, x minus 1, equals to 0, and solve for x. X is equal to 1. Therefore, the domain is the set of all real numbers, except x is not equal to 1. The vertical asymptote is x equals 1. Draw the dashed line x equals to 1. Now we need to find the horizontal asymptote. To find the horizontal asymptote, we look at the largest degree in the numerator and denominator. The numerator, the highest degree, is a 1. In the denominator, the highest degree is also a 1. So the numerator is equal to the denominator. When the degree of the numerator is equal to the degree of the denominator, then we look at the leading coefficients to find our horizontal asymptote. 1 divided by 1 is equal to 1. The horizontal asymptote is y equals 1. Draw this line on your graph with a dashed line. These are our two boundary lines. Now we need to graph. We fill out our table. To get points for the graph, pick values to the left of the vertical asymptote and to the right of the vertical asymptote. Let's start with values to the left. The vertical asymptote is at x equals 1. The x values to the left of x equals 1 would be 0, negative 1, negative 2, negative 3, negative 4, and negative 5. When we plug 0 into the equation, we get 0 plus 2 divided by 0 minus 1. 2 over negative 1 is negative 2. And we continue this with the rest of the numbers on the table. Negative 1 gives us negative 1 plus 2 over negative 1 minus 1. This gives negative 1/2. Continuing for the rest of the table, and we get 0, 1/4, 2/5, and 1/2. Now pick values to the right of the vertical asymptote, because we're looking for x values. The vertical asymptote is at x equals 1. So the next whole value number after x equals 1 is 2, 3, 4, 5, 6, and 7. This is how we pick the numbers to put in the table. And do the same thing that we did on the left table to the right table. To get 4, 2.5, 2, 7/4, 8/5, and 9/6. Now graph these two tables. This is our graph. Notice that the graphs of our rational expression will get closer and closer to the vertical asymptote and the horizontal asymptote. It will never cross these lines. Let's look at another example. Graph the function 3 over x plus 2. Get the domain first. Set the denominator equal to 0 and solve for x. X is equal to negative 2. The domain is all real numbers except where x is equal to negative 2. Since we know the domain, we also know the vertical asymptote. The vertical asymptote is x equals -2. So graph that line, x equals -2. Now for the horizontal asymptote. The degree of the numerator is 0. Since there is no x on top, then the degree on that x had to be 0. X to the 0 power is 1. So this is understood to be 0. The degree in the denominator is 1. Since the degree in the numerator is less than the degree in the denominator, then our horizontal asymptote is y equals 0. Draw that line on the graph. Now we have our vertical and horizontal asymptotes, our boundary lines. For the table, we pick numbers to the left of the vertical asymptote. The vertical asymptote is at -2. So our x value would be -3, -4, -5, -6, -7, and -8. Plug in our values into 3 over x plus 2 to get -3 and the numbers so forth in the table. Then we look to the right of the vertical asymptote. And the numbers to the right are -1, 0, 1, 2, 3, and 4. Plug these values into the rational function to get these numbers in the table and plot your graph. Notice these graphs do not touch the horizontal green line or the vertical red line. They get very close, but they will never touch. That's why they're called asymptotes, boundary lines. Graph the function x squared over x minus 1. Start with the domain and set the denominator equal to 0. X is equal to 1. Therefore, the domain is all real numbers except where x is equal to 1. So the vertical asymptote is x equals 1. Draw that dashed line. The horizontal asymptote, look at the numerator. The highest degree in the denominator is 1. The degree of the numerator is greater than the degree of the denominator. Remember, when the degree of the numerator is greater than the degree of the denominator, the horizontal asymptote is none. There is not a horizontal asymptote. To graph this rational function, we need to pick some numbers on the left side of the vertical asymptote. The vertical asymptote is at x equals 1, so the numbers would be 0, -1, -2, -3, -4, and -5. Plugging these values back into the expression results in these numbers on the table. And then we graph. Notice I don't have anything graphed here yet. Since I started at 0 for my graph, I need to pick another number that's between 0 and 1. 0.5 is easy to do. Plugging in 0.5 into the equation, I don't necessarily have to find out what those numbers are. I just need to see where my graph is headed. And a positive number squared is still positive. 0.5 minus 1 is a negative. So my graph is going to be going out positive and down negative. So my graph will be going up to 0, and then it's going to start coming back down really sharply here close to the line. Now look at the right side of the vertical asymptote. Since the vertical asymptote is at x equals 1, the numbers we would choose would be 2, 3, 4, 5, 6, and numbers on this side. Plugging in these values for x into our rational function results in this table on the right. So we need to plot these values. These values plot this part of the graph But we are still in need of this part here, the other half. Does it go this way? Does it go this way? So since our value is at 2, we need something between 2 and 1. Notice I need something between my starting point and the asymptote. Would be like 1.5. So we plug 1.5 into the equation just to see if I'm going to have positive, 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 negative, just to see where these are going. Well, positive squared is definitely going to give me a positive, and 1.5 minus 1 is also positive. So my graph is going to be in the positive, positive quadrant. This graph is going to be going up and not down because it is in the positive, positive quadrant. I'm going out positive and up positive. So we finished graphing this line. And this concludes flaps 2 and 3 in our Unit 13 foldable.